Alright, in this video we're going to talk about simplifying square roots. It's a lead into section 4.5 from Algebra 2. So let's talk about simplifying square roots. Remember, what a square root is, it's asking you what number times itself gets you the number under the square root. So the way that I find easiest to do this is to make a prime factor tree. So what numbers multiply to get you, what prime number multiplies to get you 27? Well, 3 times 9 gets you that. 3 is a prime number, so I'm going to leave that. 9 is not a prime number. I'm going to break it up to 3 times 3. I'm going to cross out 9, and I'm going to cross out 27 to make sure I realize I've used those, I've split those up. Now we have to look for pairs. So pairs here. So really we have 3 times 3. Now what we can do is we can bring that 3 out front to make it 3 times the square root of 3. That is our simplified version of this. And the reason that works is, well, what's 3 times 3? 3 times 3 is 9. And what's left inside is going to be that 3. If we square root that, remember, we can split up square roots to be the square root of 9 times the square root of 3. Well, we simplify that to 3 times the square root of 3. So from here on out, we don't need to worry about writing that piece in red there. Let's just worry about the part in blue, making our prime factor tree here. So I always like to start with 2, then work my way up. So I know 2 times 49 gets me 98. Splitting 49 up to 7 times 7. We have a pair of 7, so we can bring one of those 7s out. So this is simplified to 7 times the square root of 2. All right, now we're going to get a little bit trickier when we're multiplying these. What you could do, you have a couple different options. You could multiply the insides times each other. So I could make this to be the square root of 150. And then from there, I could start breaking it up to 2 times 75, 3 times 25, 5 times 5. There I have a pair there. We need to multiply what's left on the inside. So we're left with 5 times the square root of 2 times 3, which is really 5 times the square root of 6. Now I could do that. Or what I could do a different way is, instead of using such big numbers like 150, I could make my prime factor tree of each of these pieces. So I have 2 and 5 here, and I have 3 and 5 here. Now notice I have the 5 and the 5 right there already. And what's left on the inside is the 2 times the 6. So this simply becomes 5 times the square root of 6. Easy peasy, right? Do the same thing over here. Make your prime factor tree 2 times 4, 2 times 2, 2 times 14, 2 times 7. Now find your pairs of 2's. Pairs of 2's. So we have 2 pairs of 2's. That means we're really pulling out a 4 times the square root of 14. Multiplying what gets pulled out and multiplying what stays inside. All right, now let's remember our rules of radicals. What we can do here is we can split this up to be the square root of 9 over the square root of 64. Well, I know what the square root of 9 is. The square root of 9 is 3. I know what the square root of 64 is. It's 8. There's our simplified version. Let's try the same thing for this one on the right here, where I'm going to make that the square root of 15 over the square root of 4. Well, I can't square root the square root of 15, so I can't simplify that any further, but I can simplify the square root of 4. So this will become the square root of 15 over 2. Now there is a rule that we got to talk about, and we'll talk about it a little bit later more in depth, but you cannot have radicals in the denominator. So you can have radicals in the numerator, but you cannot have radicals in the denominator. I'm going to let you guys do these last two quickly, and I'll show you the answers in 1 second. All right, here are the solutions down there in red. So check your answers, see how you did. Now let's go into what I was talking about there a second ago. We cannot have radicals in the denominator. So when we look at that first equation up there, or sorry, that first expression there, the square root of 6/5, let's change that to the square root of 6 over the square root of 5. Now you notice neither of those can be simplified any further. So what I need to do now to get rid of that square root on the bottom is I need to figure out, well, what do I need to multiply the square root of 5 by to get rid of it? Well, I multiply it by the same thing, the square root of 5, but I can't just multiply it the bottom by square root of 5 because that changes what our actual solution is here, what our expression is. So we need to make sure we multiply both top and bottom by the square root of 5, because really, what does that equal? That equals 1. This is really the same thing as 1. And that's what we're going to multiply by. We're going to multiply by 1. So when we do that, what we end up with is the square root of 30 over the square root of 25, because remember we multiply our insides by each other. Well, the square root of 30, all that's the square root of 30. We can't really do anything with that. But the square root of 25 is 5. Now we don't have a square root on the denominator, in the denominator any longer, so we can leave it like that. All right, let's change this guy over here. It's going to be the square root of 9 over the square root of 8. Now, first thing I'm going to do is I'm going to simplify that inside that square root of 8. I'm going to change that, and I'm going to simplify the square root of 9 as well. So this is really going to become 3 over 2 times the square root of 2. Now, the biggest mistake that people make, it's not really a mistake, but it just takes more simplifying later, is they multiply, to get rid of that denominator radical, they multiply by 2 times the square root of 2. But I don't need to multiply by 2 times the square root of 2. All I need to multiply by is the square root of 2. Because watch what happens when I do that. We're going to have, on the top, it's going to be 3 times the square root of 2. On the bottom, we do outside times outside. Well, that's just 2. And inside times the square root of 4. So let's simplify that a little bit more. We have 3 times the square root of 2 over, well, square root of 4 is 2. So 2 times 2 is 4. And there's our fully simplified version of that radical. All right, I want you guys to try those last two on your own. I'll show you guys the answer in 1 second. All right, make sure you check your work. Let me know if I made a mistake here, but that's what I got. And if you guys notice, that last one is kind of a big number on top, but you cannot simplify that one anymore, because if I did make a factor tree, I'd get 19, 3, and 7. I can't split that up any further. All right, let's make our next check here. Again, we remember this, we cannot have a radical in our denominator. So we can't just multiply this side by the square root of 5, because that'll not work. What we have to multiply the top and bottom by here is the conjugate of the bottom. What the conjugate is, it's taking the same thing. So I'm going to take 7 and I'm going to take the square root of 5, but I'm going to make it addition. And so on the top, I'm going to multiply by 7 plus the square root of 5. And let's show you why this works. If I take 7 times this, or minus the square root of 5 times 7 plus the square root of 5, and we expand this out, so we do 7 times 7 is 49. 7 times positive square root of 5 is plus 7 square roots of 5. Negative square root of 5 times 7 square root of 5 is minus 7 square roots of 5. And this positive square root of 5 times the negative square root of 5, well, that's going to be negative square root of 25. Let's simplify this. If you notice, this piece right here cancels out. They go away. So we're left with 49 minus, and the square root of 5 is, or sorry, the square root of 25 is 5. So really our denominator has become 44. And that's what we want. We want it to be something that does not have a radical. So now what we have to do up on the top here is we have to multiply the negative 6 by each of those pieces there. So negative 6 times 7 is going to be negative 42. Negative 6 times positive square roots of 5 is negative 6 square roots of 5. And it'll take all of that and we'll put it over 44. Now from here we have to look what we can take out of each piece. Now the pieces we can take out of are my negative 42, my negative 6, and my positive 44. And I want to take something out that goes into each of them. If you notice, they're each even, so I can take out a 2 from each piece. Which if I take out a 2 from each piece, it's really going to become negative 21 minus 3 square roots of 5 all over 22. And there's our fully simplified version. All right, I'm going to show you guys another one over here on the right, or I'm going to do the bottom one here so I have room. And then I'm going to have you do those other first two on your own, or the right two on your own. So what do I need to do? I need to multiply by the conjugate on the bottom. So 9 minus the square root of 7, 9 minus the square root of 7, square root of 7. So now again, if I brought these over, and I'll show it to you again so you guys can see why we multiply by the conjugate here. Square root of 7 will end up with 81 minus 9 square roots of 7 plus 9 square roots of 7 minus the square root of 49. And again, you have canceling out here and here. So you're really left with 81 minus, and the square root of 49 is 7, which leaves you with 74. So we're left with 74. And I'm going to take that and I'm going to move this stuff over here quick to get it out of the way. All right, so on our bottom now, in our denominator, we have 74. And on the top, we need to distribute that -1 to each piece. So -9 minus square root, or sorry, it's going to become a plus square root of 7. Now we don't have any coefficient in front of that square root of 7, and -9 and 74. Well, we might be able to take something out, but I'm not going to be able to take anything out because we can't take anything out in front of that square root of 7. So that is our fully simplified answer. All right, I want you to try these last two on your own, and I'll put up the answers in a second. All right, there's the solution I got for those two answers. Make sure you check your work. Let me know if you have any questions. That's the end of this video. That's all we're going to talk about simplifying radicals. You're going to make sure you need to know how to do this because we're going to start to go into the quadratic formula.